What is up, everybody? It's me, your boy Sam the Bat here, back again with another video. Today though, I want to switch gears back to more of the math related content since I've not really done that much, so I thought why not start now. And I thought I'd do a topic that which I feel isn't really that well explained much in many math classes. They just give this formula. No one's really gone into detail of its derivation, at least in my experience. Only only a few good teachers I've had have explained it. Rest is, so I just thought I'd just help with that, and that is the famous distance formula over here. And then I think most of you are very familiar with this. x2 minus x1, right? Okay, so this is it, and I'm pretty sure y'all are familiar with it, but now, I want to explain to you exactly how it works and how it's based off of a very ancient but important mathematical theorem that we all know, the famous Pythagorean theorem, right over here. What was it? Sorry, it's a bit late, so my memories are really good. Okay, spoilers, my bad. We'll get to there later. So C, and then what we have is that the square of A plus the square of B is equal to the square of C. Derivation for this I could do another video, kind of like a spiritual prequel, but for now let's just keep up with this. Excuse me. So now you must be wondering, how does a formula for determining line length of a triangle have anything to do with determining the distance between 2 points? They look completely different. Like, this is just a single linear line, and this is a whole triangle, like two-dimensional shape. But if you think about it, all we're trying to do here is try to find the distance between here and here, which just so happens to be C. Not coincidentally, that's also what we're doing here. And this is how it works. Now on a coordinate plane, let's say you have point A over here, and it's, for simplicity's sake, this is just an example, don't take it seriously, 2, 2, and then point B, let me just write that, B, which is 3, 3, whatever, right? Then we have to find a distance between those two. Now, if we could somehow turn this into just for use your imagination here, and imagine that this is a right triangle, like the one we have over here. Right? Now we have a right triangle here. How do we calculate this length? Well, first we got to figure out our A and then our B. And then that's pretty simple. So if we just give each of the points, if we imagine it like this, right? What was it? Yeah, okay, let's just do it. Bear with me here. And then over here too as well. Now we have to find the difference between, we have to find this length over here, whatever this length is. What we'll do is subtract this from this. So x2 minus x1. I mean, technically this is backwards. I mean, this should be 3 and this should be 2. But again, this is just an example. I mean, I can change it if you want if it's becoming confusing. But or maybe it were like -2 and then -3, it would work like this. But yeah, now let's just see, right? So but then yeah, oh god, what the heck, dude. All right, let me change the y to y1 just for you guys simplicity. I mean, it's just an example, but I was complaining about confusing teachers, and I'm becoming a confusing teacher. What the heck? Anyhow, so x2 minus x1, right? And now if we do that, then 3 minus 2. Now we know this triangle has a height of 1. And now how long is it? Pause. How long is it? Then we have, for that though, we just have to figure out the distance between these two, which would be the, hang on a second. Okay, it's way too late at the night. It's way too late today. This is y2 minus y1. Man, I should have used the same values for both. But yeah, okay, let me re-explain. Y2 is over here. This is the 3, and this is 2. That is the value, y value of this is 3, and the y value of this is 2. So we take y1 as 2, and then y2 as 3. Now if we subtract the 2, we get 1, right? And then we do, and then the same accepts for the width. Right now over here though, we're at 3 and we're at 2. Like if we're on a number line, right? What is the difference between these two? 1. Now if we had to just calculate the distance, what we do is 1 square plus 1 square is equal to, well, obviously 2. So that means that this, and then 2, which is really, if we go by Pythagorean theorem, is equal to root 2 squared, which is the distance between these two. And now if we just plug in our original formulas back, this is x2, 3 minus x1. Okay, and then now let's just plug in these back again. We have y2 minus y1 there plus x2 minus x1 is equal to d, the distance, is equal to distance squared. And now if we just want to get the distance and not the distance squared and cause very confusing calculations for every party involved, like your height is 4 feet, but then you're telling everyone, no, like your height is 6 feet, but then you're telling everyone you're 36 feet, like, you know, it's obviously going to cause lots of problems. So let's just, if you want to just get the proper height distance, you just under root this and you get y2 minus y1 whole square plus x2 minus x1 whole square is equal to d. And that is the formula we have right over here. Again, the beauty of geometry, how you could use any shape that seems so unrelated and then figure something out from them. Now, if we wanted to attempt a quick problem with them, then I'll just show over here. Just give me a second. Give me a minute. I'm not able to find this, just right, if we had to find out the distance between, let's do part A, right? 3, 4, and I mean this should pretty much be foolproof by now, but anyway, so what we're doing though, x1, y1, x always comes first, since x, y, z in the alphabetical order, x2, y2, and now plugging this in, we have 1 minus 4 whole squared, yeah, plus 7 minus 3 whole squared. Then, you know, you guys could pause and tell me if you get the right answer or not, although this is pretty easy, so I'm pretty sure most of you will. But 9 plus 16 equal to 25, and then this 5. So the distance between these 2 points is 5 units. Alright, so I think that concludes this up for now. I'll cover more complex topics later as they come. And yeah, I hope you guys found this helpful, and see you next time.